Video 5.3 in college algebra, putting polynomials in factored form and in standard form depending on what they tell us. The first ones here, they ask us to put it in factored form. What you need to do is find the zeros first. So, since this guy right here is a third degree polynomial, he'll have 3 zeros, so 1, 2, 3. What we'll do is we'll go and graph this guy. So I have him punched in as my y1 right here, and then if I hit graph, looking for the zeros, I can trace all these guys. There is a 0 at -1. There is a 0 at 2, and there is a 0 at 6, if we take a look at all of those guys right there. And that is helpful to find our zeros, because here's what we do. To write this polynomial in factored form, you should name him either like f of x or p of x or something like that. And then since -1 is a 0 of this guy, its factor is going to be x plus 1, because if I put -1 in for x, that nugget right there would turn out to be 0. So then it would be times this guy. Since 2 is the 0, x minus 2 is going to be its factor, because 2 makes that guy 0. And on the last one of these, we'll do x minus 6, because 6 will make that 0. Pretty easy when those are whole numbers, because it's just opposite game. So on my second one here, I first got to find the zeros. There will be 4 of them due to the fundamental theorem of algebra, saying that's going to have 4 zeros. You can see what we can find by graphing them. So if I hit zoom 6 after I've got that typed in, it's kind of a messy one, especially if you have a black and white calculator. Let me make this a little bit bigger. Black and white calculator is going to be very, very tough to see that right there is a 0 at 0 in this case. There's also one way over here in no man's land, and there's another one right here at 1, 2, 3. So if I trace 3, yes, indeed, that did come out to be a 0. So 3 is the farthest most right one. There was one at 0, but I want to see if those other guys, come out rational. So if I hit my calculator instead of my email, I'm going to also have the line y equals 0 here. So I'm going to calculate where those intersect. So if I do choice 5 and do first curve, second curve, and then kind of check this dude out right here, getting close to it, that is at 1.6 repeating, so that totally is a rational number. If you're not quite sure what that is as a fraction, though, because we need them as a fraction, just type in 1.6, and you got to have like more than 9 6s to make this trick work, and hit enter to where you get the 7 to show up, and then hit math enter enter. That will change that guy to a fraction for you and give you 5/3 as a rational 0. That means that other dude has to come out rational also. So if I calculate it, second, calculate, choice 5 for intersection, first curve, second curve, slide way on over to my guess to be closer to that guy. And he is also a nice clean decimal, but we can't have any decimals. You'll see why here in a second. So -3.5 is the same thing as -7/2. If you didn't know that, you could also go back to the calculator and do math enter enter. So to write this in factored form, can't have any decimals in here. They have to all be integers. So I'm going to actually start with this guy, who is truthfully the weirdest of them all. If 0 is a 0, we don't want to put x minus 0 in parentheses. That's just silly. X minus 0 is just x. So I'm going to lead this polynomial off with x being that 0 right there. And then this guy is pretty easy to handle. He's going to be x minus 3, right? But these two fraction guys right here, here's what we got to do. There's a little trick. The denominator is going to lead off. So in this -7/2, 2 is the denominator. You're going to put an x with him, and then you just switch the sign up. Since that's a -7, we're going to have a +7. And we'll do the same thing here. The denominator leads off, put an x next to it, and then that is a +5, so we're going to do like a -5. And that'll get us to where we don't have any fractions in the parentheses, we don't have any decimals. To put it in proper factored form, that means no decimals, no fractions inside of there. So let's try that again, but we're going to skip number 3 and we're going to go straight to number 4. Because he is a 4th degree polynomial, he will have 4 zeros. I will find at least one nice boy by graphing that guy. So punch him in and zoom 6 him for a standard window. And you can see I only see 2 of those guys. By tracing those guys, one of them is at -5 and the other one is at +5. And you can trust me that I traced them and it worked out just beauty, saving you a little time on the video. That means the other 2 are most likely imaginary, so we will find them by synthetic division. So first round, there is 1x to the 4th, 0x cubes, -16x squared, 0 x's, and -225 constants. Remember those placeholders. First guy comes down, then multiply on the outside, and then add them up. That's a positive 25 right there, and then add those up and get yourself a 9, and then a negative 45, and add those up, and then this guy does turn out to be 225. We get ourselves a remainder of 0, which is supposed to happen. Then, of course, we got to synthetically divide by the other guy. Don't forget it doesn't matter what order you do those in, so they just both have to happen. Let me clean that up a little bit because that is just a 5, and then add them up, 0. 0, 9. 9 times 5 is 45, and those totally add up to be nothing. So the whole point of this was to knock him down to a quadratic. This is 1x squared plus no x's plus 9 constants equals 0. This is awesome that we don't have to like factor it, which it wouldn't factor anyway, or complete the square on it or use a quadratic formula because there's no x's. So if I just subtract 9 from both sides and then I square root, like, you know you're going to get imaginary answers. 9 itself is a perfect square, so you're going to get plus or minus 3, but you need to stick an I with it right there. So one of those zeros is 3i, the other 0 is negative 3i. Don't forget that imaginary guys come in conjugate pairs. But we weren't looking for those for a final answer. That's just part A. We got to write our polynomial in factored form. So I'm going to call him f of x equals, the first parenthesis would give me a factor of x plus 5. The second one would be x minus 5, and then this one would be like x plus 3i and x minus, actually it would be minus and plus, but it really doesn't matter because they're both there. But since that is a positive, that would be a minus, and then this one would be a plus 3i. It's just kind of weird. We usually don't see them like that, but that is factored form of this when it's got imaginary guys. So the next section is way easier. It says find all the zeros of these guys. It is given to us in factored form already. That is amazing sauce because when it is in factored form, the zeros are just the dudes that make that guy 0. So this 0, what makes him 0 is negative 1. What makes him 0 is 3. And what makes him 0 is the opposite of this guy over that guy. So negative 5 over 2. That would make that 0 in that case. And then on our next one here, there's a cool little interesting thing of this quantity being squared. So we'll deal with him in a second, but 2 would make him 0, 6 would make that one 0, and negative 7 makes this 0. But because it is squared, that's going to have like multiplicity. So we'll say multiple of 2. And if we graph that guy, there would be a point of tangency at that place. That's where the graph like touches the x-axis but never crosses over. There's always an even amount of zeros here because it's got that multiplicity. So interesting, right? They say on 7 and 8, form a polynomial function in factored form from these zeros, so they just want us to do the same thing. It's the same thing as 1, 2, and 4, but they literally gave us the zeros, but they add in this multiplicity junk. So f of x, right here, they give me a 0 of 2. That means x minus 2 is going to be its factor. Got him done with. They give me this 0 of minus 5, so x plus 5 is going to be that factor. And then the last one would be x minus 3. They say the whole thing will end up having degree 3, and that's true because if you add up all these exponents out here, it adds up to be 3. Degree 3 means there's 3 different zeros. We have them all. But on this next dude right here, when we write our factor, don't forget f of x equals, they say negative 3 is a 0, so x plus 3 is going to be a factor, but since it has a multiplicity of 2, that quantity gets squared. And then on this next 0 of 2, that's going to be x minus 2. He doesn't have any multiplicity. And then the last guy right here, since he's a fraction, the denominator leads off. You put an x next to that, and then it's the opposite of that first dude. He does not have multiplicity of 4. They're just saying the entire degree of this polynomial is 4. So if you add this up, there's 1, 2, 3, 4. Right? This 0 shows up twice, so there are 4 zeros on that guy. To the back side here, it says answer these questions regarding these polynomials. They say list every 0 and its multiplicity if bigger than 1. So what's kind of weird about this guy is all these nuggets. There is a pink nugget, a green nugget, and a blue nugget right here. The blue and the green ones are no problem. It's that pink guy that gives people a lot of confusion. The pink guy doesn't matter one bit because it doesn't have x's with it. It is just a constant. It has no x's. So everything that makes this guy 0, 5 is a 0. It doesn't have any multiplicity bigger than 1 because that parentheses being raised to the first power. The blue guy, -3 is a 0, but it has multiplicity of 2. So we always kind of throw that in parentheses after that, meaning -3 is a 0 twice because that is a point of tangency. Then they ask us for the real zeros listed and tell whether it crosses or touches the x-axis. What we'll do is we'll make a little chart here so we don't have to keep writing the word crosses and touches out many, many times. So crosses and touches, it will cross, the graph will cross the x-axis if it has odd multiplicity, be it multiplicity of 1, multiplicity of 3, multiplicity of 5, multiplicity of 7, any odd number, and it will touch the x-axis, aka a point of tangency, if it has even multiplicity, be it 2, 4, 6, 8, whatever. So 5 only has multiplicity of 1, so he is odd, so that crosses the x-axis, and -3 has even multiplicity, so it will touch the x-axis. What is the degree of that polynomial? You just add up all your zeros. There are 2 zeros right here and 1 more 0 right here, so that's got degree of 3 in that case. What is the maximum number of turning points? It's like the exact opposite of what we did before. To find the degree, we did turning points +1. When we have the degree, we got to do degree -1 to go back and find the turning points in that guy. And draw a picture of the end behavior. Since he is 100% odd, the ends are going to go different ways. Which way do they go? It depends on that leading coefficient. So downright negative is where this guy is going to go. And since they're supposed to go different directions, that other dude goes to the up. So the guy on the right goes down because it has negative leading coefficient. So doing this all over again, this one is much more challenging. First, this pink guy is very different than before. Then this guy is normal, and this guy is normal, but the one that I haven't highlighted is very strange because it has like a squared inside the parentheses instead of like on the outside. So we're going to deal with that one that I didn't highlight last. The pink one totally matters this time as compared to before because he has an x with it. What value of x makes this 0? It's like 5 times what would give you 0 back? That would be 0. It has just multiplicity of 1 because that is like x to the first power. Then, skipping over that dude for a second, the green one, -5, would make him 0. He's a normal boy, but he's going to have multiplicity of 4 due to that 4 being raised on the outside. And then the last guy right here in blue, opposite of this guy, over that guy, would be 4/3. He does not have multiplicity other than 1 because that is raised to the first power. But to find these other zeros right here, the way you do that is you literally take what's in the parentheses and set it equal to 0 and like solve for x. Like you're just trying to see what makes it 0. So I will subtract 9 from both sides, get a -9, and then I will square root. That's going to come out imaginary, so plus or minus 3i. So 3i is a 0 and -3i is a 0. Weirdo right there gave us some imaginary zeros. For each 0, it says list it, and for each real 0, it says list it and tell whether it crosses or touches. So I'll make my chart again. Crosses versus touches. It will cross if it has odd multiplicity. It will touch if it has even multiplicity. So odd multiplicity is 0 because he's got multiplicity of 1, and 4/3 had a multiplicity of 1 in that case. The 3i and -3i aren't real, they're imaginary, so they don't even count on this list because we're only listing the real zeros. And -5 has even multiplicity, so he's going to touch it. There's a point of tangency. What's the degree of the polynomial? We're going to count up all our zeros. Here is 1 of them, 2 of them, 3 of them. I'm going to skip over here to be 4 of them, plus 4 more of these, right? So that is actually 8, because that one showed up 4 times. That's what multiplicity means. What is the maximum number of turning points? So that's the -1 trick, because you do turning points plus 1 to get the degree. Draw a picture of the end behavior. Since he is even, they are both go in the same ways. Since the leading coefficient is positive, they shall both go up. Little side note, it probably doesn't matter because it depends on what x is. If x is an odd number, then they're both going to open down, but we're going to go with the fact that it didn't have a negative, so we're rocking with that. And then finally, the least favorite thing that we do is take a polynomial and put him in standard form. Boo this. The factored form was all the parentheses stuff. The standard form is where you got to multiply it all out. So how do you do it? Start with factored form and then multiply it out. So here we go. I'm going to write f of x equals, and you see, like, I'm going to kind of cheat around a little bit. You're always looking for 0. 0 is a weird nugget right here. If 0 is a 0, you're just going to put x. Remember, it's not x minus 0, but he also has a multiplicity of 2, so that's actually x squared. So I've taken care of that guy. Then the other dude is got a 0 at 6, so he's a normal friend. It's just going to be x minus 6. But the thing is, this is factored form. They don't want that. But we need it to get started with. To put it in standard form, we need to multiply this out. And this ain't too bad. It's just a distributive property. So x squared times x is x cubed minus 6x squared. So there's our final answer on this. That was not a bad one. Here, they're trying to be little bitty cheaters on this because they only show you 2 zeros, and it's got degree 3 because you're supposed to know that imaginary zeros come in conjugate pairs. So if 3i is a 0, so is negative 3i being a 0 on that one. So to write them in factored form, I'd have f of x equals x minus 4 for this dude right here, and then x plus 3i, actually it'd be x minus 3i, I always do that backwards, x minus 3i times x plus 3i on that. And we have to multiply these out. You can't multiply 3 things in a row times each other. If you did like 3 times 5 times 10, like you have to do 3 times 5 first, which is 15, and then you take that times 10. So you like totally want to multiply 2 things at a time. And here's the thing. It'll work any which way you do it. If you multiply these conjugates together first, man, life will be easy. Because conjugates, something special happens when you multiply those out. So this green x minus 4 is just going to have to wait a minute. I'm going to multiply these out. How, of course, do you do it? FOIL. So first terms times each other, x squared. Outside guys times each other, plus 3ix. Weird. Inside guys, minus 3ix, and the last terms is going to be a negative 3 times a positive 3, which is a negative 9, but you got I times I, which is going to be I squared. So I FOILed that out. Here's awesomeness. First of all, those should add up to be nothing. Negative 3ix plus positive 3ix add up to be nothing. That should happen when you multiply conjugates together every time. In the FOIL process, those always add up to be nothing. But it's been a long time since we dealt with I squared. The thing about I squared is he is actually equal to the number negative 1. If you remember, I was defined to be the square root of negative 1, and if we square both sides, this is what happens. I squared turns out to be negative 1. So this number right here is really negative 9 times negative 1, which is a plus 9. And then there is an x squared right here as well, so I'm going to kind of clean this up a little bit prettier. This group right here is x squared plus 9. The middle canceled out, and then this guy has an I squared with it, which means we got to take whatever that nugget was times negative 1. Crazy thing, Mr. Blue Dude hasn't been dealt with yet, so we got to bring him down, and now we could FOIL these again. So first terms, x squared times x is x cubed. Outside guys, 9x. Inside guys, minus 4x squared, and then last terms minus 36. And then what I'll do is just kind of clean that up and put it in like proper notation, like standard form, to where the highest degree comes first, the next degree is the x squareds, the next degree is the x's, and then this guy. And man, if we graph this dude right here, it would be a odd degree. He's got 3 zeros. We'd see one of them to be 4, but the other 2 we wouldn't see because they're imaginary. What an awesome thing, man. So, man, let us know if you have any questions because I went fast. Let's have a good one.